we'll be working with pandas and datetime data to see how we can actually perform some applied operations with pandas. So it always happens that we have data from two different data sources. And if I look at these data, I can actually see, okay, it looks like my top data frame has values every 3 days, where my bottom data frame has values every 2 days. So these were collected at different times, but I need them to align in some fashion so that I can work with them if I want to directly compare them. And if I want to directly compare these, well, one of the main things that we reach for in pandas when we want to compare two different data frames is our trusty index alignment. And so if I set the index to both these data frames to be the date, and then I add them, we get, oh man. So we get the union, okay, right, we get the union of our index. And then wherever these dates don't align, we get nans. But wherever they do, we successfully added these two dates together, which is great for us. But what if I wanted to find the nearest date? You know, you would think that maybe some type of left merge would give us this result, but this left merge is just aligning actual date values and not finding the nearest match for us. And so when we want to align dates based on a nearest match, or maybe we want to align a future date to a past date based on two different data frames, we can use this merge as of. And by using merge as of, I actually pull data from both of my data frames, and I say, all right, in my left data frame, or my X, right, as they refer to it in pandas, my first date occurred at January 5th. What's the closest value that corresponds to that date in my right-hand data frame? And it'll grab that and it'll fill that value in. And it does the same thing with every single value. We can also pass in a tolerance, right? If I only want to grab dates that exist within 1 day of my left-hand data frame, I can pass a tolerance with a day of 1. And so we can perform really powerful and very fast, right? This is all written in Python. That's why this merge as of function exists as a separate entity all unto its own. Perform fast comparisons in order to align date times that might be sampled at different rates that don't overlap with one another. Additionally, if I wanted to perform this merge operation by hand, this merge as of, I can show you that. First, we would actually perform a cross join. And so we're aligning every row in my left-hand data frame with every row in my right-hand data frame. And then we perform some type of temporary column calculation where we would get the difference, the absolute difference between the dates in my X data frame and the dates in my Y data frame. And then from there, we would perform a grouped indexing such that we would get the minimum difference between the two columns, and we would print it out. And we can actually maintain, right, how different were these 2 days? Well, it turns out that these 2 days actually perfectly aligned. This has a difference of 1 day, and so on and so forth. We can see here that if we wanted to pass around tolerance, we could perform some type of filtering operation on this date diff column. We can also use some reshaping and reindexing tricks to perform different types of analyses. For example, we can perform a year-over-year analysis. And so if we started out with some revenue data, now let me go ahead and show you what this looks like. So if we look at this revenue data, we see that we have some earnings or reportings for every day, it looks like, between 2015 and 2019. So quite a lot of data here. But what if I wanted to compare, right, all of the monthly data in 2015 to all the monthly data in 2019, kind of doing a year-over-year analysis or comparing the months to each month. So this answers the question, am I doing better in January of 2019 than I did in January of 2015? And we can ask that question to every single year. And so where we would start this analysis off is we would start by resampling our data. And so we would take our raw data and we would resample it into monthly bins. We would select the revenue column. I want to keep this as a data frame, so that's why you see the double square brackets here, but you'll see why in just a moment. And then within our monthly bins, we take the average. And now our revenue data come out looking like this. So instead of dealing, with hundreds and thousands of days. We just have a few months here to work with, binned within each year. And then what I can then do is I can actually extract the year and the month that these data exist. And just so you are aware, I'm printing out just the top 5 rows and the bottom 5 rows of my data, and that's why you're not seeing all of it. But I can extract out my year and my month as separate columns, right, just by accessing that portion of the index and assigning it as a column. And then what I can do with these, first, I'm going to want to get the year that I compare to. So if I want everything relative to 2019, I would get the maximum value from my years. And then I need to subset my data, and there's a couple ways I can go about doing this. The first, I can pivot my data, and if I pivot my revenue based on my month and my year, I kind of end up with a table looking like this, where all my rows correspond to each month of the year, and my columns correspond to each year. And what we could do is we could take that 2019 column and we could subtract all the values from 2015, 16, 17, 18 from it, and then we could divide by those original values to see relatively, are we doing better in 2019 than we were in these other years? And so I'm actually taking my comparison year here and I'm subtracting it from the original data frame. So wherever you see this as negative, I was actually doing better in that year than I am in 2019. But I don't like all of this reshaping. This pivot is actually not a super fast operation. What I can do is actually leverage some of Pandas' index alignment a little more efficiently. So I can do away with my full fidelity datetime index because I'm really only interested in the years and the months. I could carry it around if I needed to, but just by setting my index to year and month, I can then subset using .lock, get my comparison year out, so that'll just extract this bottom chunk of my table here, and then I can subtract it from the rest of my data frame. And when I use the .sub operation, I can pass the level in that I want to perform my index alignment on. When I do .lock, I'm removing this 2019 from these values, and so all I'm left with is the month. And so I want to make sure that I'm lining up months to months instead of month against the years. And so I can do that, and I can actually perform this same analysis. I can pivot it out later if I want to actually, have some human readable data, but typically when we're working with data in this fashion, the long format is easier to work with for performance reasons. We can also perform interpolation that's datetime aware. And for you, if you're not aware, interpolation is simply the smart filling of NaN values. And so if I were to take this data frame and simply plot it, you can see here that I have 3 points and the rest are missing data. These lines would be connected, but there's NaNs in between them. What I can do is I can actually perform a linear interpolation, and all this is going to do, it's going to fill in the rest of those dots first of all, but it's going to connect them just in a straight line. But Pandas is a little bit smarter than that. We know that this date is much closer to this first NaN than it is this next date. What I'm saying here is there's a difference of 28 days between these two dates, but there's a difference of 3 years between these two dates. This is some information that we can apply in our interpolation in order to perform smarter interpolating. These data were generated from an exponential curve, and you can see here by using this time-aware interpolation, we actually recover a little bit more of the model than we started with, than if we just use this linear combination. And that is how you can perform, or that's how you can work with date times in Pandas. You have a plethora of choices and approaches that you can use to perform different analyses.